So, it is my pleasure to announce now the next speaker. So this is going to be Katharina Kohls, and she's a professor at the University of Bochum, and she is also head of the chair for system security group. And so the work of her group focuses on security and privacy of mobile network infrastructures. And before leading this group, she was also an assistant professor at Radboud University. And before that, she was also a postdoc at Bochum University. And so, yes, today Katharina is going to talk about extracting user locations from mobile instant messengers. Thank you, Katharina. You can start.
Thank you for the introduction, and thanks for having me. So, exactly, this talk is going to be about learning someone's location just from sending them a couple of messages. So, the context of this whole attack that we're going to look at is that let's just assume we have a person waking up, realizing it's such a nice day and they're supposed to work. And they think about their office setup and the boring desk and the boring computer, and they look outside the window and say, all right, the sun is shining. Even though I work from home, it's so boring. I want to go swimming instead. So they're sitting at home, right in the dilemma of going to work like they're supposed to, or going to the beach instead, and wondering if anybody would notice because you work from home. Your boss can't see that. What should happen? What could possibly go wrong? So in our story, our person decides, okay, let's just sneak off. Let's go to the beach, enjoy the sunshine, drink a glass of juice, stare at the sea, have a nice and relaxing day. So they start taking off. And instead of going to the desk in the home office and sitting there in front of the computer the whole day, our hero just takes a detour, goes to the beach, and enjoys the day, enjoys the sunshine. The problem now is, while relaxing, the phone goes ding and they receive a message coming in from Eve. You're not at work. And now our hero is a bit concerned because how would anybody know that? How would they be able to realize that they're not in the home office working, because nobody can look inside. Nobody would be able to see that. But still, someone caught our hero. So what's happening here? We have one person, Eve, who's the attacker, sending a message to another person, and they're very interested about the location of that person. So I just sent a message, and in return, they received the location of the victim. This is basically what this talk is going to be about, and what the background of this attack is. You send a message to a person, and then you can determine the location of that person. So that's a setting that we're going to start with. Eve sends a message and learns the location. And that's quite a bad setting, because I would assume, I can't see the audience right now, but I would assume that everyone might be carrying a smartphone and that everyone might have sent a couple of messages already today and maybe received a couple of messages. And that's what you need for this attack. You send a message, you analyze a bit of data, and then you get the location. And that's kind of privacy sensitive, because location is important information. So this is all part of a paper that's called Hope of Delivery, Extracting User Locations from Mobile Instant Messengers. We published that at NDSS in 23. And it was, and you will see that later in the measurements, it was a joint project at different locations. So in Germany, the Netherlands, and in Abu Dhabi. And what we will focus on, what's very important here, is we want to extract user locations. So you reveal a location without any consent. It says mobile instant messenger. So wherever you carry your phone, you carry your device, wherever you take it, that's where you might be localized. And it's using instant messengers, which is like a group of apps where it's very likely that you're going to use them. So you already use them on a daily basis, and the adversary can exploit these mobile apps. So this is our setting. This is the context that we will work with. Big question, how is this possible? And we won't go into detail with everything. That might be a bit too much and be a bit too boring. But I'll give you the general concept of how this works. So there's a fundamental principle that we can make use of here. We look at information from transmission times, because time, speed, and distance are related. That's a very obvious relation. When you go somewhere by car, by train, or whatever, then that vehicle travels at a certain speed, and this allows you to travel somewhere in a certain time, and you manage to travel a certain distance. That's how they're all related. And we can make use of that. We can learn time and speed from transmitting information, so we can get the distance. And getting the distance means that we can get information about locations. And that's a very simple concept in general. So when you are somewhere and you do a timing measurement, you send out a probe to that point, you wait for the response, you can measure how long that takes. So let's just say it's 20 milliseconds to send something back and receiving the response. Then you can take this very simple equation, speed times time equals distance, and you already got the time. And we can just assume a speed. We can just say it's when we transmit information on the internet, it travels at the speed of light. Disclaimer, it does not. The internet is slower, but this is pretty much the upper bound that we can get right now with our technology. The highest speed that we could achieve transmitting information is the speed of light. So we measure 20 milliseconds back and forth. So the distance, let's just say it's 10 milliseconds for one direction. 10 milliseconds times the speed of light equals to roughly 3,000 kilometers. So if you transmit information, then the maximum that it can travel in that time is 3K. That's it. And this allows you to draw a circle around your location where you're currently in, with a radius of 3,000 kilometers. And that is your search space. That's a rather big search space right now for our example, but it already gives you the idea of what we will be doing. You measure timings, you assume a certain speed, and then you get an area where you can search. And by doing this a little bit smarter than this, you will be able to localize users. So this is the fundamental concept that we're going to apply in this attack. That's what we're going to make use of. How does this help us? You get a plausible search space. So this is Europe. I just put the point somewhere. I just drew a circle around that. Just an example. It's a rather big search space, but if you have multiple measurements and if you can make it smaller and if you have more information, then you get quite good information and a lot of hints and pointers that help you to narrow down the location of a target. And that's what we're doing in this attack. So, how does Eve localize our hero in the story? That's the main question, and we will approach this now from a more technical perspective. We need to find out how things are connected. How can we measure timings? How can we derive distances? How does this help us? And what can we accomplish with this? So we get a task list. First item is we want to send a message to the target. This is something that you can do with your phone. If you have someone in your address book that you can send a message to, this is a person that you would be able to attack with this whole concept. Then Eve needs to analyze the timings, because just sending a message doesn't give you enough information. You have to analyze the timings. And then you can check the plausibility of a location. In our example, our hero was supposed to be at home working at the desk, but they wandered off to the beach, which is a totally different location because their home office is not located at the beach. And this is what Eve can do. She can check the plausibility of the location she gets from the analysis. And we'll just go through these tasks now step by step and see how this can be accomplished. And we'll begin with the part where you send a message to the target. And the big question is, what can we learn from that? So when you send a message using one of these instant messengers, what you most likely will get is you have the sender, which is you with your phone. You have the receiver on the other end, that's the person that you target, but you will have at least one intermediate server. So just following the example of WhatsApp, if you send out a message, there will be a first check sign that you get when the message arrives at the server. So when you send out a message and you see this check mark right to your message, you know it now arrived at the server. And then the server forwards the message to the receiver. And then on the way back, you get a notification that the message now arrived at the receiver. So if you have two check marks, what you learn from that is your message arrived at the sender and at the receiver, and the acknowledgement of that took all the way back to you. So one check mark gives you the back and forth to the server. Two check marks give you the back and forth from sender, server, receiver, server, sender. So the whole way back. And we can use this information. So first point, messengers use intermediate servers. This gives you these check marks and we can make use of that. First part is we know how long it takes until the message arrives at the server. So this is the time between sender and server. And we can get the time it takes from the sender, from the server to the recipient and back. This is the double check mark. And deriving these pieces of information from the transmission, from the message that you send, this gives us the information that we need for the attack. And for this, what's very important, we know that the server is the intermediate node. We are interested in the destination, so the recipient. So we need to learn where the server locations are, because if you just take one of the check marks, you don't get the recipient. That doesn't help us. And if you take the two check marks, that's very good because the message arrived at the recipient, but we still have this hop in the middle of the intermediate server. And that gives us a lot of noise if we would just take this timing from the double check mark. But if we know the server location, that's one more piece of information that we can use, and that helps us a lot with the localization. So let's see where the servers are located. We looked at different prominent instant messenger apps in our paper. And when you start looking for server infrastructure, you get no public information for Signal. You get some hints that Threema has servers in the Zurich area. And for WhatsApp, it's pretty much clear that they will use the infrastructure of Meta. So the whole server infrastructure of Meta might also be used for WhatsApp, or at least parts of that. So what can we do? We can collect empirical information about the servers to learn more about the server infrastructure. So how many are there? Where are they located? How are they picked? Is there any strategy on how to pick the server if there are multiple servers in the connection? So this is one big preliminary step that we have to accomplish before we can conduct the attack. And how do we do that? Well, we can't just ask. It's information that they're not likely to share, but we can just measure that. Just take a bunch of phones. You write a script, and with the script you send a lot of messages to other phones. And if you record the traffic, what you get is a long list of IP addresses. So if you send out a message, the destination IP is the server, not the recipient, because the server is the intermediate hop. So whenever you send out a couple of messages and you record the traces, you will get the destination IPs of the intermediate servers. And if you send messages from different locations, then you get additional information telling you that there might be multiple servers, they might be in different locations, they might be picked according to your location, so maybe trying to be as close to you as possible. And by using like different measurement times and a lot of repetitions, you get data that helps you understand the infrastructure a bit more. So we did that. We took a couple of phones, we sent out a lot of messages using scripts, and then we received a very extensive IP data set that we could analyze to understand the server infrastructure. And what you can do with IP addresses, I mean, they're not very interesting just as the plain numbers, but what you can do is make reverse DNS lookups and extend the IP information with more stuff. Whatever you can get your hands on, whatever is useful for understanding the infrastructure. So the example that we look at right now is just asking for the DNS records of an IP address that we saw in our measurements. You get the host name for an IP address. This whole thing only works if there's a record existing and if it's properly configured, but we will just assume that that's the case. And what you see here, underlined in red, is the host name of one of the meta servers that is used for WhatsApp. So it's got still Facebook in the name, and what you see is a rather long string indicating a couple of different pieces of information. So for WhatsApp was very interesting because there are a lot of servers worldwide, and they use these IATA location codes. So when you look at the host names that you get from the IP addresses, then you get these these short codes in red that you see here, and they already indicate a location. So LAX is Los Angeles, LHR is London, CDG is Paris, and so on. So just from the IP addresses and the host names, you get locations that definitely point to a place in the world and where you can locate the server and the according IP address. This is something that's only possible for WhatsApp and the meta infrastructure. It helps us to verify assumptions about locations because IP addresses and geo-IP information is not always reliable. But these are very good pointers for us to get the locations. And after doing this, sending a lot of messages, collecting a lot of information, this is what you get. So all the green dots that you see, that is infrastructure from WhatsApp. You see some dots in the ocean, which is a very good indicator that empirical data is not always perfect, but the majority of these points is reasonable and can be used for our data set. You also see that there are not so many signal and Threema servers. So Threema, we assume them in the Zurich area, and this is still correct. And then the signal server is on the East Coast in the US. And this is already an interesting picture because you see that WhatsApp has a lot of infrastructure. It is the biggest messenger of the three. And it also means that the load is well distributed among these servers, whereas if you send a signal message, it will travel to the East Coast and it will travel back. So there might be longer delays here. And for WhatsApp, you have less noise of these long detours. And this is now information that we can use in our model and that we can use for the localization. Because we send a message, we learn the arrival time at the server, we know the IP address of the server, and we now know the server locations. So we can estimate which server was used, and we already have, it's like a longer equation, and we can put in a couple of numbers here, and we can remove a couple of the question marks in the equation. So this helps us identifying where the receiver is located, because the first part of the connection we already kind of check out. So this also checks the first item on our task list. We send out messages using one of these popular instant messengers. We get delivery and receiver notifications And we can time those, we can measure those. Like if we look at the transmissions, we record them, we analyze them, we see when we receive one of these check marks or the double check mark. And we can know the server infrastructure because we have empirical data about that. And it is not 100% correct, but the majority of server locations are. And we can rely on that and use that for the next following steps. So next step would be analyzing the timing that we get, because we're not so much interested in the server, but in the destination. So there are a couple of challenges here. Whenever you do timing measurements on the internet, you have to assume, you have to expect that they vary a lot. There's a lot of noise in the transmissions because you have dynamic routing. The route that information takes is not always the same. You have congestion, depending on the time of the day, it varies a lot what performance you can get. The receiver might not connect to the same server as you do. So there's more noise. There's one more hop that you don't know about because it's behind the server and you don't see any IP address. That adds noise as well. And locations can be very easy or very hard to guess. We'll see why that is the case in a couple of minutes, but as a short notice on this. What Eve can do is check whether the person is in a certain location. And if locations are very close to each other, it's very difficult to be sure about the exact location. Whereas when you have to distinguish between two different continents, it gets easier. So we analyze the timing now, and we have to send a lot of messages again, back and forth. So what we can do for our experiments, and what is also part of the attack, we prepare a labeled data set that we train on. For that, we send repeated messages. We have the same setup again. We have phones in different locations, and we know these locations. Those are the senders, and we have receivers in different locations. We know them again, so we have a labeled data set, we have a ground truth, and we can test different messengers. So we just keep on sending messages, and we use the different instant messengers on the phone. And all of this results in a classification problem, because we have receiver locations, for example, countries. Those are the classes, and we want to find out, based on the timing, where what class the receiver is, what location the receiver has. So by sending out all these messages, we generate a huge labeled data set. And we can now use this data set to check the plausibility of a location, to conduct this final step of the attack. And because so far it was an interesting attack concept, now we get to the scientific parts again. It's not that we run around and attack people. We have to define different scenarios, and we have to define different goals. We have to analyze the performance to see how reliable the attack is. So there are 4 different things that we are interested in, that we covered in our paper. First one is, what is the receiver's country? So there's a list of potential target countries, and we want to find out which one it is. So it's not an arbitrary guess of at what geolocation is our target anywhere in the world. It's about finding out if they're in one of these known countries. Then it's a binary question. Are they within a country? Did the person of our story, did they leave the country to go to a beach in a different one? Are they still here? Where are they exactly? This is very challenging. So it's not so much about a country in a very large search space. It's more about, is someone in the ID building on the RUP campus? Are they in the MC building? Are they in the Audimax? Are they in the gym? This is very difficult because it's all the same city. And finally, what connection do they use? Because it can make a huge difference to be on a Wi-Fi connection or to use a cellular connection. So these are the 4 questions that we ask, and we try to apply our classifier to find this out based on timing information. So in our experiments, we send a little more than 240,000 messages in different combinations, different countries, different locations, different devices, different apps. And we use this data set to find out, or to give a first indication whether the attack would work. So what we do, like you would do in any scientific work, you have your large data set, you split it up a couple of times in a big training set that you can use to analyze and prepare, and a small test set that you then use to analyze what performance do you get. And then for each sample, we get the probability that it belongs to one of the classes that we're looking for. We can compare the results with our ground truth, so we know where we did a correct guess or a wrong guess, and we use a neural network for the classification. And I won't go into detail with all the results that we had. I'll just give you an example of identifying the receiver country. So this was the first of the 4 questions that I listed. And what you see here is basically a confusion matrix showing whether a guess was made for the right destination. So on the diagonal line in the middle, you see correct combinations, and you want to have a high number there. And every other combination would be a wrong guess. And what you see here is that for the majority of guesses that we did with the classifier, it was possible to find the right match for the destination country. So you see the overall results for the different messengers on the right, and it ranges between 74 and 84% of correct guesses for the different messengers. Which leads to the conclusion, yeah, in general, it kind of works. So for a task list, this means we can send out a message, we can analyze the timing, we have empirical information that we can use that helps us, and we can use this to check the plausibility of a location. Like we have our classification challenge, and it seems that we're successful with that challenge. So, conclusion, we can guess the location of the receiver without their consent. Big question is, what's the catch? And there are quite some limitations to this. First one is you have to obtain a training set, and that can be very annoying for the target because it basically means sending messages over and over again. So if you're somewhere and you keep on receiving messages over and over again without any useful content, and it's very conspicuous, that's an indication that something is going on that's not supposed to go on. I don't think that people run around and actually implement this attack, but this would be a very good indicator. So first limitation is obtaining a training set might be very conspicuous, especially when you just keep on sending repeated messages to a target. Second limitation is the attacker model. It is a very nice and simple and smart attacker model, but it is not a very common one. You can conduct this attack when you know the victim, and you need the phone number or the contact of the instant messenger, and you need to know the locations that they're usually in. So if Eve knows that our hero is either at home office or at the beach, it's rather simple to find one of these classes, just based on the timing, especially if home office and beach are very far from each other. But if there are new locations that Eve doesn't know about, it might be very difficult to find out where exactly the user is located, because you don't know that location. You can't really narrow it down just from this attack. So the attacker model has limitations. It is very simple because you only have to send messages, and instant messengers are everywhere. But the attacker has to know the victim, and you cannot make an arbitrary guess on any location. You can just verify known locations, which is, it's still nice, So I could send a message to someone, like to one of my students, and verify whether they are in the office or not. But it's not that I can just take an arbitrary person and say, you are located right in this, at this latitude and longitude. And then finally, disabling these delivery notifications would remove the source of information that you need for the attack. Not all apps allow that, but it would be a very simple fix and like a defense against that attack. And this brings me to the conclusion of my talk. So what should you take home? First important aspect is that transmission times contain information that points to locations. And that is not a concept that is limited to this attack and messengers. It is a concept that applies to everything that has a transmission speed and a time that you can measure, and that then relates to a distance. That's a concept that you can apply everywhere. Then you can implement an attack that's based on timing information, and you can augment this whole approach with empirical information, like the infrastructure of servers. And then eventually you can send messages to guess the target's location. And on paper, this is a successful attack. It does work. There are some limitations. And you always have to keep in mind that the attacker model is rather specific about the requirements. And this brings me to the end of my talk, and I'm happy to answer questions.
Okay, let's start with questions in the room.
Hey, thank you for your talk. So the attack involves only one instant message, right? Did you try to, for example, in WhatsApp that has multiple servers all around Europe, did you try to send 3 or 4 messages each to a different server and try to triangulate and find more information about the user, about the victim?
That's definitely something that you can do. You would need multiple devices and multiple locations for that. And the problem is a bit that you can only influence your server. So the destination will connect to their own server. So it's not like in a classical setting where you can really just have multiple references and then narrow down the search space of the destination, because you always have these intermediate servers. It would definitely help, but it is not as simple and as straightforward as in GPS.
Yes, thank you. Any other questions? Yes.
Hi. So if I want to defeat this attack using Signal, can I just draw a circle on a map around the east coast of the US and only go on vacation on the circumference of that circle?
No. No, because it would, like, if my location, if I'm the adversary, my location is static, then, and the server is static as well, then you moving around will introduce differences in the timing. I mean, if you stay very close to the server, I won't be able to localize you. But otherwise, it should be possible to still localize us, to still narrow down where you're supposed to be.
Hey, Katharina, thanks for your talk. I was wondering, in your measurement, did you assume that whenever people are at home, they're going through the Wi-Fi network, or do you also consider that they might change to like mobile network if they, like, let's say, move to another place in a like at home?
So we did experiments with Wi-Fi and cellular connection because the infrastructures are so different, and In a cellular connection, you have more noise, more overhead, because you have to route through the core network and then the intranet. We didn't have a scenario where we would have a user that changes in the middle of the experiment or something like that. But we do have experiments covering distinguishing Wi-Fi and cellular, and that works as well. So we are also able to distinguish what kind of connection you're on.
Hello, Katharina. Hello, Katharina. This is Savio from TUI. A question: can this same technique be used, for example, by the WhatsApp provider or any other provider to localize users?
Yes, because the delivery notifications, well, I'm not sure if you would need all this overhead of this attack. What the WhatsApp server sees is the destination IP of the delivery notification that's being sent out. And they see the connecting IP address as well. So they pretty much already have IP information about your location. And it's like IP information is not always perfect. So you could try to improve what you get out of that, but in most of the cases already reveals your location. I mean, if you go on one of these web pages where you check what your IP address is, you always get location information as well. And as soon as you have an IP address, you have location information.
Okay, thanks.
Thank you. I see some more questions. Yes.
Yeah.
Hi, thank you very much for your talk. I was wondering, modern chat apps like the ones you've covered typically provide some way to, set up voice calls, and this typically happens using a protocol called WebRTC, which sets up peer-to-peer connections. It's obviously a well-known attack vector that this allows you to identify the IP address of the other party. And so these services offer a proxy that allows you to hide the IP address for the other party. I was wondering, have you considered doing the same timing attack for voice calls with this proxy server in the middle?
We have not. And I would assume that is a very similar setting. The question is what piece of information would we use for the timings? Because what we use right now is the delivery notifications, and they help us to localize the server and then already have certainty about that part of the connection. So you would still need information about the proxies that are being used. But I assume that because you have a similar source of information, a similar type of attack would be feasible.
Yeah, so the reason why I'm asking is in this situation, you have a bidirectional audio stream. And so you could maybe use this as a continuous stream of timing measurements.
Yes, you would definitely have a lot more information to use for the attack. It's like repeated messages, and more data is always good for timing measurements on the intranet because of the noise that you get.
Okay, thank you.
Thank you. We have another question.
Have you also considered the scenario where the victim of this attack is using roaming on cellular network? That usually involves that the traffic is relayed then back to the home country. This will make this kind of attack an effective, right?
So we would have a setting with a cellular connection for at least the victim using roaming. Then it depends on the roaming setting, because you can have a local breakout or what was the other one called? So there are two different options where you have the roaming partner connect to the home network, or having I think it would be much more challenging because you have a lot more hops in between. But the roaming setting itself is also something rather static that the adversary would be able to learn. It's a bit like the server infrastructure of the messengers. You can also learn the infrastructure of mobile operators because it's very similar, and I think they have way less servers than WhatsApp uses. So yes, with this implementation, it would be very challenging, but it is static information that the adversary could also train on.
Okay, thank you.
Okay, we have time for one more question, and then the
That was
rest.
someone else.
Okay.
I'm sorry.
No problem.
I have to be fair.
Hi, thank you for your talk. When you presented the accuracy results for the guesses at the end, out of your 3 apps, I noticed that while you have WhatsApp, which has, as you said, a lot of different servers, Signal and the third one, whose name escapes me at the moment, seem to have a big gap in their accuracies, even though, unless I understood wrong, they both use central servers, one in Zurich for the unnamed one and one in the East Coast for Signal. Have you explored why there's such a discrepancy between the two? Because it seems, at least to me, maybe naively, that having central servers would make them behave similarly, or maybe one of them has more noise. Have you explored why there's such a big difference?
We didn't explore that. My assumption is that the Threema server in the near Zurich is much closer to the reference points where we conducted our measurements. So we have very strange, the locations where we conducted measurements are pretty much biased by where we do research. So they're in Germany, Netherlands, Greece, and in Abu Dhabi, which is all pretty far away from the East Coast, but around the Zurich area. So we have less noise. And my assumption would be that this influenced our results. To an extent where you see this difference between, it's I think not so much about Signal and Threema, it's more about East Coast and Europe.
Okay, thank you very much, Katharina. We have to move on. For the rest of the questions, maybe you can put them online. Let's thank Katharina again, please. Okay, we continue with the next session. So here we have Maarten Hundscheid. He's part of the Totem game development team. Yeah, this is the first and only game development team, student team at the TUE. And Maarten specifically, he's a researcher and creator with the drive to develop gamified solutions for vulnerable groups. And today he's going to talk about one of his works.
Yes. Thank you very much. So today it might probably be a slightly different talk compared to the rest of today. We're going to look more into how to apply certain things. So we created an application called the Eye that aims to teach high school students about the dangers of facial recognition technology. And today I'm going to talk a bit about facial recognition technology itself, how to apply it in a gamified solution, what we actually made. And of course, afterwards, there's room for questions. My name is Maarten, so I'm part of student team Totem Game Dev. So like was already mentioned, we're a student team here at the TUE focused on game development and game development solutions. I function there as the educational officer and the gamification manager. So I'm responsible for all the gamification topics that we do and all the educational topics that we do. So a nice combination is this sense. Before I go into more of the topic, I want to show a short snippet of what the current state already is of facial recognition technology to provide a bit of context.
Both glasses that will identify anybody on the street. The information of those glasses in just a photo of the face is static. Use it, if you just put the glasses on, then as you walk by people, the glasses will detect when somebody's face is in frame. This photo is used to analyze them, and after a few seconds, their personal information pops up on the photo. Right?
June Lee, right? You're from Bergen County Academies? Your Korean name is Yoon?
No? But are you, let's see. Oh, okay, I think I met you through like the Cambridge Community Foundation.
So this is a bit of a small context that 2 students from MIT were just able to use these glasses, run the software on it, go to whatever place they want, scan whatever person they want, and if there's data on them, act like they know this individual. So in theory, not to say that everyone in this room is easy to find online, but I could walk to someone in the back, look at them, act like I've met them 3 years ago at a specific event, like this event, and just gaslight them basically into believing that we already know each other. And that's, of course, quite dangerous in a sense. And it's important that people know these kinds of technologies already exist. To provide a bit of background, especially in this context of high schoolers, is that every day 1.3 billion videos and images are posted to social media like Instagram. And of course, these social medias are generally used for gathering information, posting your opinion, providing some entertainment. And it's used by a large group of the current Dutch population. So in Dutch high schoolers, it's 87.2% that uses social media every day, is constantly posting photos, uploading it to these databases, and spending 4.8 hours on average every day on their phone on social media. And this can be on platforms like Instagram, on Snapchat, TikTok, Blue Sky, whatever. There's a wide variety of options, of course. But in reality, only 53.2% of people are actually aware of what facial recognition is and what it means and how it functions. And I find it very important to make people aware, especially this demographic, why they should or should not post maybe certain images or things on social media. So if we give a bit of an explanation of what facial recognition is, it's a biometric technology. What in short means that similar to your fingerprint or your pupil, it's a unique identifier for an individual. So while some people might have something very alike, or there are always duplicates in some sense, your face is quite unique. So everyone in this room will have a unique face, I assume, and have their own way of being able to identify it. And this technology, its main purpose is the identification and verification of these faces in a certain context. So what you see, some very easy examples are like access to your phone. For the people, especially with iPhone, I know I can look at it and it opens up my phone. Very easy context, but that's already facial recognition, right? My phone knows who I am, how I look like, and it allows me to log in very easily, very nice. Or if I place something on Instagram or social media, it automatically is like, okay, I saw this person, I'll automatically tag them for you if you want. So it already immediately applies this to the images you upload. But of course, in a more serious context, it can also be used to identify dangerous individuals in certain environments. For example, if I go to the airport and some camera sees that there's a man who is maybe gonna do something violent, it's better to already have that person in like inside beforehand than if something happens afterwards. So, like I said, a very iconic application is the mobile phone in different contexts as well, not only to log in, but also currently in China, they are using it in classrooms to see if the students are paying actually attention to the teacher. And it's very basic in the sense of if they don't look at the board, they're not paying attention and their mark gets deducted. And if that's a correct way of using it, I won't say, but it's already a very functional application of it. It's also like with the Ray-Ban Meta glasses, which I already showed in the video, also a very easy application. You could in theory just be wearing the glasses and it functions and no one would necessarily know. Or at the Olympic Games in Paris, they actually already used this kind of technology to make sure everyone was safe by using it as threat detection. And they're currently still debating whether they should be allowed to maintain it after the games have happened, because some people feel it's a privacy concern and other people feel like, oh yeah, but it does create more safety for people living in the city. So basically, facial recognition is a part of machine learning combined with a big data set and making some form of prediction. So that can be a picture, which you put into the system. It extracts certain features from you, it classifies it, and you give a certain result. So if I grab this handsome individual, which you might have seen before, you put in a picture, It extracts some points, for example, where my eyes are, where my mouth is, where my hairline is, where my chin is. It will compare them to some other things in the data set, maybe a specific face of me, or just generally if it's a face, and it will provide you with an answer, okay, it's a face. This is, of course, a very basic example of how it functions, but just to get the concept. And a big issue behind it is that faces can already be recognized from a distance without requiring any permission. So even someone sitting in the back, if I use my phone camera, it could already identify them, but not necessarily people in the back have given permission that I can do that, right? And that's a big issue. While there are several benefits, like I said before, there's security and public safety. In certain contexts, of course, it's nice that it's a safe environment where people that want to maybe do violence can already be detected. Or if it's a dangerous situation that's happening, you can already be prepared for it. It's very convenient, it's efficient. I also like that my laptop automatically logs in when I look at it compared to having to type in my password. And it helps with some technological advancements in the context of, if you take this even further, maybe you can look at a face and already see, okay, this person has some form of sickness. However, on the downside, because when you have benefits, there are often also downsides. These algorithms are always based on some kind of data set. And these data sets often introduce quite a lot of biases. So, for example, if I have a very European or Western data set, it might have difficulty making conclusions about more of an Asian population, because the data set just doesn't know, and it will always make a result, and that result can be faulty. You will also often give immediately like an oversight and over-reliance on the technology. So if I go to some industry, like if I go to some factory and there are cameras everywhere, I should assume that the company that has the camera, it doesn't use my data maliciously in any way. But I cannot know, right? Maybe you can assume, okay, in the Eindhoven city center, there's a camera and only the government can see it, so it's probably fine, or not, it depends on everyone's opinion. But if I go to another company or a factory or another city, can you still trust or believe that it's fair? And that goes on to the part of the privacy rights and ethics about it, because I don't give permission that if I walk in Eindhoven city center, that my face can get registered and put in some data set. Is that fair? Is that not fair? And the laws are not really up to date to this point yet, because it's already applied in the field, but there is no specific rules about the ethics and the privacy concerns behind it. So how we approach this is by trying to make these 53% of people that are not aware of this technology, we want to make them aware, specifically in this age group of 14 to 18-year-olds. And we want to use gamification and integrate it to create a more stimulating experience for those students. Because you can assume, if I give them a textbook about facial recognition technology, they might read it, maybe they understand it, but they might not remember it. To give an introduction into gamification, because it's a very important concept for this topic, for this application, of course. Gamification, the term itself was followed by Nick Pelling in 2002, a game developer. And it basically means introducing game elements in a non-gaming environment. So if I give a very practical example, I can introduce a leaderboard in the classroom and the best students get a cookie, right? By integrating this leaderboard in such an environment, you already create kind of a stimulating or a less stimulating or motivating environment, make it playful in a sense, and in that way create that the best students will try to be better and better, or maybe the third in line will try to be better to become the first, get more cookies, whatever. And that's a very easy way of introducing such a game element in such a non-gaming environment. Some very practical examples to illustrate what this could also mean. So you have the piano stairs, and here the idea was, okay, if we have a set of stairs and an escalator next to it, we want to make sure that more people try to take the stairs. Because taking the escalator is quite lazy, people get fat, let's just make them do the stairs, but let them have the autonomy and choice of taking the stairs. So what they thought is, okay, what if we make the stairs actual functioning piano tiles? So every step of the stair will make a sound. And what they found is that many more individuals decided to just use the stairs instead of the escalator because, oh, it's fun to make music and jump around and make some melody or whatever, maybe do it with your children. And you really see that it already, with such an easy application, motivates exercise in a certain group or audience. Another example is Folded, which was used to do some protein research. So some researchers thought, okay, we want to do more research in protein structures. And with the data set they had, they could do it, but it took a long time and they couldn't find new things. So they thought, okay, if we make a simple puzzle game, maybe 50, 100 people play this game, maybe they find some results, maybe not. And eventually 10,000s of gamers started to play the game every day, produce huge sets of data, which they still haven't been able to all handle and analyze. And it actually helped find new protein structures. It actually helped find some medicines. And that's a very easy way of supporting research by just creating a simple puzzle game. And one example everyone knows, I'm not the favorite of it, but it does exist, and it's a good example of gamification is Duolingo. So it kind of gamifies learning a language in the sense of it tries to stimulate learning by integrating leaderboards, bonuses, rewards for daily streaks, very gamified elements that you see in other games as well, and introduce it in an environment where it might stimulate you to learn. Because, of course, if you've done 5 days in a row, why not do the 6th and earn your sticker? Right, and then the 7th gives you a cookie as well. You don't know, and this very easily already stimulates this learning environment. So in short, gamification can really help with illustrating goals. Where are you now? Where do you want to go? And how do we get there? And what games do you need to play? It can help stimulate the users where, okay, I'm the second in line, or I'm the first in line, or if we do it together, then we can win X, and really helps you get to certain goals and thereby support certain performances from the users. By stimulating such users in the environment, they will learn more and therefore their performance will increase as well. It is, however, very important to mention the difference between intrinsic and extrinsic motivation, in the sense that if I am intrinsically motivated, it means that the motivation comes from me. So I want to do this because I want it. Well, from extrinsically, it's because some outside body or organization said that, oh, if I give you this, you'll do it. And what you often see, of course, in gamification is if I give you a reward every time you do something, you're very extrinsically motivated to do it instead of you do it from within. So the whole idea of these games, or if you make a game that's meant for like a good social purpose, is that you start with some extrinsic motivation to get people hooked and interested into the topic, so that eventually, once they are actually known about the topic, they start to be motivated by themselves and want to know more about this topic. But gamification is quite broad, as you can assume, and as you can see. There are a bunch of ways where I can apply some gamification into some context where you can apply it, have fun, and learn. Some examples, of course, include healthcare, maybe manufacturing, making it fun to put a box together, or, of course, education, which is what we're talking about today as well. If you take the context of education, we often call it edutainment. So we move from A to B. So the gamification version of education is edutainment. And something that Walt Disney in 1954 was highly interested in and was a very big person for, because he wanted that entertainment needs to go past purely entertaining. He felt that it's valuable to also teach a topic while entertaining an individual. And that can be through giving a simple piece of information about a country or calculating or whatever, just so that if you watch a movie, it's also just educative for the people that watch this movie. And when you look at edutainment, it can help, similar to gamification, really stimulate this learning performance, because you're playing a game, you're learning about it, and that makes you better at things. Problem solving, in the sense that you are often expected to play such a game alone, so you have to give the solution instead of someone that stands behind you and tells you, oh, okay, this is the answer, or this is how you do it. You have to figure it out yourself because you play this game as an individual, so it's very self-directed. In collaborative games, of course, you learn to work together to find a certain solution, which helps you communicate as well. For us, we tried to combine this facial recognition technology topic together with entertainment and us Totem. And this is a short sneak peek trailer of what we made. This is purely to get you interested, right? But I'll explain what it actually is, because of course that doesn't say much. The eye in short is meant to be, is gonna be, or is a mobile application that aims to teach facial recognition technology to high schoolers by using play in some form. And we always do this client-based. So we had a client this year called Night of the Nerds. Some might know it. They had an event yesterday, which you were at as well. And they are a creative tech expo every year here in Eindhoven, or sometimes on tour in other environments. And they said, okay, we would like you guys to make a game that teaches facial recognition technology awareness for this specific target audience, with the goal to increase the understanding and stimulate discourse. And we thought we can do that. And that's hopefully what we did, what you will see. So to give a short background on what the story is and what the game is about, is that you take the role of kind of a government employee. And you're meant to review cases and determining the guilt of people by looking at the pictures. So think, for example, a security guard sitting behind the security camera, looking at someone doing something suspicious and saying, okay, that's a dangerous individual. And the idea is that you, as the government employee, are tasked to train a facial recognition technology system and see if it aligns with what's actually the truth. And eventually throughout the game, which is 26 cases, you'll slowly be replaced by the system where it starts learning better and better, where it's like, okay, no, so now it can take over. And you'll see that it will discuss topics like the biases that might exist within the technology because the data set is incorrect. We'll also talk a bit about image generation. So when it's actually a real image, situational snapshots, maybe a picture was taken in a scenario or moment, but didn't paint the whole picture. Deepfakes, so putting your face upon someone else's body, and many more. And we do this by giving a short introduction into the game. You play the game, not really a tutorial, just to get you immersed into the story. Then we give the tutorial. So once you're immersed, you can actually be part of it. And then we have 26 different topics, which you go through one by one, get some information about it, analyze the different images, make a certain reflection. So you see if you're correct compared to the system and what the actual result was. And eventually you'll get to some conclusion, which I won't spoil for anyone that wants to play the game. It will include this kind of twist, which is very important to this topic. And we did this through 3 different steps in a way. So we created an app, we created a toolkit, and a learning module. Because we felt that only an app, of course, I can give a student an app, they might play it similar to a book, and they'll play it, maybe learn something, maybe not, and then forget about it. And we thought at least it's important to supply some additional information for students that feel like it's valuable, or for parents, or for teachers, or whoever has some intrinsic motivation to learn about this topic. And this app we made quite simple because you don't want flashy colors and distracting things. We want to keep it serious and realistic. And we tried to make it in a sense similar to the mobile applications and the social media applications that the target users use. Because like I said before, 87.2% of them use social media. So they probably know how to swipe around and press the buttons. And if you make the application very similar to what they already know, it's easier for them to utilize such an application. So we made it very simple. First, you see some information about the person you're going to be analyzing. Then you see them in a certain scenario where the face was found. Then you make a certain judgment about them. Okay, I feel like this person is very dangerous because maybe he stole something, maybe he didn't. And then eventually I go on to a reflection page where it says, okay, I said it's dangerous. The system said it wasn't dangerous. And the actual situation was that yes or no. And then you get a kind of a reward for it. So congratulations, you did correctly, or unfortunately, you did not. To really stimulate those users throughout this process, get them motivated, getting to play the whole game and go throughout the story. Like I said, we also have the toolkit. The toolkit is realistically purely meant to support the app. So either you go to the toolkit first and then go to the app, or the other way around. And here you can find information, maybe interesting ways to introduce it to family members, your children, maybe if you're in a classroom setting to your peers, and really provide the ways of teaching it. So, okay, first I recommend doing this step, introducing the topic. Okay, then we'll go on to playing a simple game. And this website will highlight all of this step by step. So if you want to learn about this topic or use the game, you have a support tool for it. Final thing we made was a learning module, which is in collaboration with the 4TU Alliance. So that is an alliance of all the technical universities here in the Netherlands, which created basically an application environment, like a website, where they can create modules on specific topics, and teachers, if they want, can go onto this website, find the topic they find interesting, have a 50-minute module with presentations and tools and whatever, immediately use it, apply it. And like you can see, here are some examples. Of course, unfortunately, it's all in Dutch because it's for Dutch high school students, but you can learn about CRISPR-Cas, how to work with AI or generative AI. And one of them will be how to learn about facial recognition technology, and that will also include our app. And it's basically meant as a standalone module where teachers, if they want, can introduce it into their classroom environment. We aim to publish our game on the App Store and the Google Play Store, which is going to be happening this month. Not right now yet, because there were some bugs we found yesterday. So, and as always, of course. So we'll still be continuing working on it, so it's done this month, and then it will be available for anyone that's interested. Like I said before, we're from Totem Game Dev, so we're a student team here at the TUE, but basically what that means, it's an extracurricular activity for students that next to their studies want to engage in a certain environment or goal. So it can, for us, be working for game development, it can for other students be organizing a conference about energy, sustainability, or building a race car, whatever you find interesting. For us, it's if you're interested in doing something with us or learning more about us, we have a website, a LinkedIn, and an Instagram, and you can scan them if you want. We'll also be here today. If you want to test the game, you can ask questions there as well, or connect with us. We have a stand there on that side. Yes, on that side, where you can talk to me, talk to my colleagues, and learn more about it. That's basically what I have for today. So if you have questions, feel free to ask.
Yes, thank you, Maarten. Do we have questions in the room?
So thanks for this interesting talk. Have you already like tested out with an audience of students?
Yeah.
And did you like survey them afterward whether they learned something or not? Like, was it effective?
Yeah, so our first user test was without a survey. So that was just to get them user testing it for the basis of, does this function? Because it's more important to first see if even the application works before giving them an educational thing where the application doesn't even work. And then, oh yeah, wait, they didn't learn anything because the thing is actually broken. But we currently have planned for this month as well a user test at an actual high school with the current students. To see that they learned something, what did they learn, what did they feel about the application as well, what should be different, what motivated them, that kind of stuff. So really we already have our ethical approval for it. We're currently planning that with high school, so yes.
Yes, thank you. Next one. You had some hands raised in, no. Yeah. Okay, well. No.
Just asking. Okay.
What I also really like, in addition to the previous question, like what I also wonder is whether people or students are going to change their behavior as a result of this. Do you have any predictions?
Well, I feel it's meant to make them aware about it, right? It's completely up to them. If they want to do something with the information that they have, at least that they know that it could exist. And especially within this future where everything is changing slowly, right? At least from my experience. If everyone starts wearing the Ray-Ban glasses and knowing each other and basically gaslighting that I already know you, I feel it's at least valuable for them to know. I know that in the environment where students exist right now is not realistic that they won't post anything to social media anymore or less or different things, because realistically it will maintain the same, but at least want to make them aware about it. And that's our biggest goal.
Yes. So may I ask in between, first of all, how long is approximately like the playing of the students? And then also, did you do some type of, engineering that really boosts engagement? Because you don't have exactly the same use case. Like, for instance, you mentioned Duolingo. That one is really focused on everything addiction inducing. I guess yours is to play once and then...
Yeah. The idea is not for you. Of course, if you want, you can play it 20 times. That's already fine. No, the idea is really to have one standalone experience with it, learn from it, have the twist, and that's it. And that will be 1 to 1.5 hours. So that's already quite long because every case will take you about 2 minutes. 26 cases times 2, 52, and probably take you a little bit longer. But overall, we've designed the game with specific things in mind to make them more engaged and interested in it. And that can already be from the sound behind it, because sound is a very large, important part of engagement in games, to 20 other things that we did in the background, from color to movement to distractions. Another fun thing we implemented is while playing the game the whole time, there's a little eye that follows your finger around, which seems very silly, right? But in reality, when you're playing the game, it's some kind of engagement and motivation, like, oh, it's following me, right? And it feels silly, but the first time I saw it functioning, I actually got a bit unnerved by it. And these are already small details that we integrated to create this kind of engaging environment.
Yes, another question.
Thank you for your presentation. How important is it to, when you're designing such an educational game and try to develop a story, to really have a passion about the ethics around this subject? Could you do this as a service, like give me new technology, I'll make an educational game about it? Or was it very important, especially for developing the story, that you had some personal investment in the technology?
For me, I noticed, especially also within the context of the team that we have, that it's very important that you're also motivated yourself about the topic, because otherwise you at one point won't like developing it anymore. Because if I work on this every week, every day, whatever, but I hate the topic, eventually either my work is gonna be bad or I'm not gonna work anymore on it, I'm gonna be distracted. So I felt that if you want to work on this, you also should be interested in the topic. And if you're not interested in the topic, it might not be best to work on it. Of course, you can become interested into it. When I first saw it, I was like, okay, it sounds cool, but what does it entail? But after working on this for a year, I'm like, okay, I really understand the concept. I do like teaching this concept. This is also why I'm here today. So it's not that you can't become motivated, but if you have nothing to do with this topic, then I wouldn't recommend. But there are a bunch of companies also in Eindhoven and the Netherlands that just do it as a service. So they just say, okay, we'll make whatever you want. That functions, of course, from a business perspective, but I don't find it a realistic option, personally.
Hi. So one thing I was just thinking about during the talk, and I'm still trying to figure it out now, when I'm thinking about other examples that I know of that are things that have been gamified, there's always, in the ones I can think of at least, some kind of reward, you were talking about intrinsic versus extrinsic motivation. I mean, there's some motivation to do the thing, right?
Yeah.
And it sounds like in this game that you're developing, there are both, I guess, positive motivations, but also like negative incentives. Like you were talking about the eye that follows your finger around. I mean, it's kind of creeping you out, maybe a little bit, or it should. Maybe that's the intention. But can you talk actually maybe just a bit more about the specific like concepts of gamification that you were trying to incorporate? Just maybe to clarify, like when you're playing the game, what is the thing that makes me want to play this and learn more about facial recognition? And is it indeed based on like my intrinsic motivation to educate myself on the topic, or are you also kind of addicting me somehow with these kinds of other tactics? So just clarify that would be cool.
Yeah, no, it's two sides. I'll give the biggest example because there are a bunch of minor ones. I'll give the biggest example and another. So the biggest thing is, it keeps track of your score constantly. So you're doing it correct, you're doing it incorrect, and you always want to be correct. Like as humans, let's be honest, most of us wants to be correct in life. So constantly you're playing this game, you're leveling up, which is already a big example of gamification, because leveling up, becoming better, improving, growing. But then at the end of the game, you'll be able to see your score. And the idea is, because it's part of like a classroom experience, you can also go back to the classroom and as a teacher say, okay, who got this score, who got that score, and you can go back in the game, try to get it better, improve, learn from it. It's a one-time experience, right? But if you feel like you did very bad because the rest of the class is better, you might be more motivated to do it again, learn more from it. So in short, the ranked list concept, but also the getting better, promoting, becoming better. But overall, we also design things like I mentioned before, the audio design in there, which is less of the gamification part, but for something like we want to create a fun game, right? So the whole concept behind the game is that next to that it teaches you a topic, which if that's the only goal, it's eventually quite boring. It's also just a fun game. So the whole game is designed to even be playable if you don't want to learn about FRT at all. It's just a fun game. And then behind all it is that you'll secretly be learning about facial recognition technology.
I was wondering, like, is there maybe it's a spoiler, but do you record the user's face during the game, and do you transform it somehow, or like incorporate it in the game?
It's part of the twist, not gonna lie. So the player is made aware by it, so don't worry that while you're playing the game it's constantly recording. But there is a moment that the player will interact with the game in some capacity and something happens to their face later on. But I won't spoil it because it's a big part of it. But basically, yes, in some capacity.
Okay, are there any more questions? It seems not, so yeah, let's thank Maarten again.